Today we're going to be talking about probabilities of independent and dependent events. So independent events. Independent events happen when the probability of A does not affect the probability of B occurring. So you can think of that like I flip a coin and pull a card out of a deck. Okay, so flipping a coin isn't going to affect which card I pull out of the deck. Now, dependent events are the probability of A occurring in some way changes the probability of B. Meaning, so I pull a card out of a deck, I don't replace it, and then I pull another card. Okay. So example 1. Determine whether the event is independent or dependent. Explain your reasoning. A dice is rolled, then a second dice is rolled. So a dice is rolled, then a second dice. So they're two different dice. So this is an independent event. Okay. There is two different dice. Okay, and then a card is selected from random, not put back, and then a second card is selected. So this is dependent. There's one less card in the deck. Okay, so here's some formulas. There's a lot going on this slide. I immediately regret putting this slide on here because there's a lot going on. So the probability of two independent events is just the product of them. So product of A and B is just product of A times the product of B. A key word you're going to be looking for is and. And then probability of two dependent events, okay, is the probability of A and B. And so it's the probability of A and then the probability of B given A. So what this is the probability of A given B. Okay, so let's do some examples. I think, and I have one example planned. Let's do one example and hopefully this will clarify things for you. So Michelle and Christina are going out to lunch. They put 5 green slips of paper and 6 red slips of paper into a bag. Person draws a green slip, they will order a hamburger. Draw a red slip, they will order pizza. That sounds like something I would do. Anyway, so there's 11 total slips. Okay, so suppose Michelle draws a slip, not liking the outcome, she puts it back and draws a second time. What is the probability that on each draw her slip is green? Okay, so what that means is, okay, let's do the probability of the first times by the probability of the second. So, draws a slip not liking, so I need to know the probability of a green. So there is 6 green out of a total of 11. She puts it back. So there's a total of 6 greens still left in there out of 11 total slips. So I have 6 times 6, which is 36, over 11 times 11, which is 121. Now the next example. Suppose Christina draws a slip and the slip is green. Okay, that's important. Not liking the outcome, she keeps the slip, so she's affecting it. What is the probability the second is red? So we have to do our first probability, which is our probability of green, times by then our probability of red. So our probability of green, there are 11 total slips in my bag. Of them, 5 are green. Now she doesn't put it back, so there's 10 left. And the second is red. I have 6 red. So then simplifying that, 5 times 6 is 30. 11 times 10 is 110. I simplify and I get 3 out of 11. Lastly, suppose Michelle draws a slip, does not put it back, then her friend Christina draws a slip. What's the probability they both pick green? So I need a green times by another green. But there's a key word in here. She does not put it back. Okay, so that's going to be really important to us. So I have 11 slips that I start with. Both friends draw a green. Well, I have 5 green slips. She doesn't put it back, so there's 10 left over. There's no longer, since this first one was green, there's 4 green left over. So we have 20 over 110, and that simplifies to 2 over 11.